Hey guys, Mrs. Dalton again. I am back for the rest of the study guide. Number 8 says Vincent buys 7 tickets for a movie. Each ticket costs $6.25. How much does he pay for all 7 tickets? Okay, well, this one is a multiplying decimals question. So we're going to take 6.25 times 7. 5 times 7 is 35. Carry the 3. 7 times 2 is 14, plus 3 is 17, carry the 1. 7 times 6 is 42, plus 1 is 43. There are 1, 2 decimal places, so 1, 2 decimal places. And the grand total is $43.75. Number 9. Mrs. Bates sells bookmarks for $2 each to raise money to purchase new library books. So far, she has collected a total of $220. Which equation below would solve for B, the amount of bookmarks that have been sold? Okay, so we know that bookmarks cost $2 each, and we know that she has collected $220 altogether. So the only thing that's missing is our variable of B for bookmarks. So it would make sense that we figure out how many bookmarks by taking the $2 times the B, or the bookmarks, equals 220. Your answer choice is letter C, which is correct. And you'll notice that 2B is the same as 2 parentheses B, because remember, when you have a variable and a number next to each other, you don't have to put the parentheses to show multiplying, okay? Letter A doesn't make sense because you're not going to take the number of books plus $2 to get 220. Letter B is not going to make sense because you're not going to take $2 minus $220. Or sorry, you're not going to take the number of bookmarks you sold minus $220 equals $2. And letter D doesn't make sense because you're not going to take the number of bookmarks divided by $2 to get $220. So bookmarks, or $2 times each bookmark, equals $220. Letter C. Number 10. Gavin records the expression below, 7 times y. Lane wrote an equivalent expression below, y times 7. Which property explains why the expressions that Gavin and Lane wrote are equivalent? Okay. So back when we did properties of operations, we had one where the items in the expression just switched places. And if you move them around, it wasn't going to change the answer. So this guy is actually the commutative, and I hope I spelled this right, commutative property of multiplication, or just the commutative property. Okay, that's where if you change the order, it's not going to make a difference. You're still going to get the same answer. So commutative property of multiplication for number 10. Okay, let's see. Number 11. Which situation is best represented by the integer negative 20? Okay, so letter A says Colton had 20 times as much candy as Louie. So 20 times Louie would be the representation for this expression. We're looking for something that represents a negative 20. Okay, Zane bought 20 items at the store. So if Zane didn't have any items before he went into the store, and then he bought 20, then that would be a gain of 20, which would also, for number 1, would be a gain of 20, which would be a positive, because he has 20 times as much as Lane, which means he's got a positive amount, integer. All right, letter C, Benny evenly split the pizza among 20 people. Okay, so that means pizza, sorry, just kidding. We could use a variable P for pizza divided by 20 people. Okay, and then that would be the expression or the situation. And then letter D, Michelle went down 20 flights of stairs. So she is at ground level in a building, and she goes down the stairs. She is moving in a negative situation 20 flights of stairs, not 20 stairs. But anyway, that is a negative situation because she is losing elevation. Okay? So in this case, answer is D for number 11. Okay, number 12. You have to put the ordered pairs from the graph for each point, okay? So remember that your coordinates have to be x first and then y. So that means you're always going to go side to side first and then up or down second, okay? So let's look for point A. We're going to start at our point of origin, 0, 0. We're going to count over 1, 2, and then we're going to count up 1, 2, 3, 4, 5, 6, 7, okay? So 2 over, 7 up. Letter B, we're going to start at our origin, and we're going to go 1, 2, 3, 4, but that's a negative 4. And then we're going to go up, which is 1, 2, 3, 4, 5, 6, and that's a positive 6. Okay, letter D, I don't know where C is, but we're going to go with D next. Start at your point of origin, 1, 2, 3 in a negative direction. And then 1, 2, 3 in also a negative direction. Okay. Letter E, we're going to start at the point of origin, and we're going to go over 0 and up 2. So we didn't move anywhere on our x-axis, but we went up 2 on our y-axis. And then F, we're going to go 1, 2, 3, 4, 5, 6, 7 in the positive direction. And then 1, 2, 3, 4, 5 in the negative y direction. So remember, over and then up, side to side, and then up and down. That's always how you're going to find a point on a grid. Okay, number 13, find the value of the expression below. Okay, here's another PEMDAS, parentheses, exponents, multiply or divide, or if you see division first, then you're going to divide and then multiply, and then add or subtract, or subtract and add, whichever one you see first. Here are your steps for PEMDAS, or your order of operations. Okay, so we're going to start with our parentheses first. 7 minus 5 is 2. Bring everything down. Okay, parentheses, check. Exponents, all right, 3 to the second power. Remember, 3 to the second power means 3 times 3, which is 9. Bring everything else down. Okay, multiply or divide, yep, right here. 9 times 2 is 18. Bring everything down. And then 4 plus 18 is 22. Answer to number 13. Okay, number 14. Julie and her 5 friends earned $432 at a bake sale. They agreed to split the profits evenly among them. How much should each friend make? Okay, so when I was walking around in class this week, I noticed a lot of you were doing 432 and dividing by 5. What is wrong with that? Question mark. Okay? It's in your first 5 words. Julie and her 5 friends. So this is actually 432 divided by 6 people. Okay? 6 does not go into 4. Put a 0. 6 goes into 43 7 times. We'll give you 42. Subtract and bring down. 6 goes into 12 twice. And no remainder, so each person will get $72. Number 14. Okay, number 15. Which expression is equivalent or equal to 3 divided by 1/5? Okay, so we've got 3 divided by 1/5, and this takes us back to question, I can't remember, 2 or 3, anyway, where we were dividing fractions. Okay, so remember when we divide fractions, our rule is multiply by the reciprocal or keep, change, flip. So I'm going to keep the 3. I'm going to change the sign to multiply. And I'm going to flip the 1 over 5 to 5 over 1, which looks most like, oh, there it is. Answer choice D. Okay, number 16. What is a prime factorization of 156? Okay, so 156 is kind of a big number, but it ends in a 6, which tells me it's even. So anytime it ends in an even number, I can divide by 2. Okay, 2 goes into 7, or 1 0 times. 2 goes into 15 7 times. Subtract. Bring down. 2 goes into 16 8 times. And no remainder. Okay, so I know that 2 times 78 is 56. 2 is prime, so I'm going to circle it. Now I'm going to break down 78. Again, 78 is even, so I'm going to divide by 2. 2 goes into 7 3 times. Subtract, bring down. 2 goes into 18 9 times. No remainder. Okay, so 2 times 39. 2 is prime. And let's break down 39. I know that 3 times 13 is 39, but I'll go ahead and show you in case you want to see. And there it is. Okay. So 3 is prime, and so is 13. So you would actually write 2 times 3 times 13, but then you're going to write it again with your exponents. 2 to the second power times 3 times 13 is your final answer. Okay, number 17. Students voted for their favorite type of restaurant. The table shows the fraction voting for each restaurant type. Order the fractions from least to greatest. Okay, so in this case, this problem was a little easy because all of the numerators are 1. So we are talking about one slice of each kind of restaurant. Okay, so remember, when we're working with fractions, the bigger the denominator, like 12, the smaller the piece. So if you look at this fraction of 1/12, that means you take something, you cut it into 12 even or equal pieces, and one of them would be all that you would get. That would be a very tiny piece. So that's going to be your smallest piece. Okay. 6 is going to be our next largest denominator, but next larger piece as well. And then 1/4, and then 1/2. So if I have a half of something, it is much bigger than the rest of these pieces. Now, this was easy because everything had a 1 in the numerator, and all we had to do was look at the denominator. But if you have a different numerator, it's not going to be so easy. So you would have to find the least common denominator. So you, for instance, for 2, 12, 6, and 4, okay, in case you had to do this on your final or on your semester exam, you would list your multiples of each denominator to see what the first one they have in common is. And I would start with my largest number because you can cover more ground, 12, 24, 36, and I'll stop there too because I know that 2 will go into 12, 2 will go into 6, and 2 will go into 12, 12 will go into 12, 6 will go into 12, and 4 will go into 12. And if you listed your multiples, you would see that 10, 12, and then 6, 12, 18, and then 4, 8, 12. So our least common denominator would be 12, and you would have to change all of your fractions. So 1/2 times 6 on the top, 6 on the bottom would give you 6/12. And 1/12 would be good to go. So you would leave that alone. So 6/12, 1/12, and then 1/6 times 2 over 2 will give you 2/12. And then 1 over 4 times 3, top and bottom, would give you 3/12. And if we put them in order from least to greatest, they would also still be in the same order. 1/12, 2/12, 3/12, and 6/12. I know it looks like a 4. That's a 6. Okay, I'm running out of time. I'm going to make one more video. See you in a minute.